Hello, let's continue our Sudoku adventure with Rudolf Clausius's Finest Moment by Randall. So we have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have entropic lines in the grid, actually just single entropic line in the grid. Very, very long one. The way this line works is pick any 3 adjacent cells along this line, like these 3, these 3, these 3, these 3, like just pick any 3. And every single one of the 3 adjacent cells on the line have to have one digit from each group, the low, the medium, and high group. So 1, 2, 3, 4, and 5, 6. So for example, these 3, if I have, say, a 2 here, then within these 3, I already have one representative from the low group. I need a medium and a high. So the high might go here, for example. This could be a 6, and then this could be the medium, say a 4 or a 3, right? And that fulfills these 3. But do keep in mind that, for example, these 3 would also have to. These 3 would have to. These 3 would have to. These 3 have to. We have to do that for the entire line. All right. And other than that, we just have some crop key pairs here. So digits separated by a white dot are consecutive. So if this was 2, this could be 1 or 3, according to the dot. And the entropic line disagrees. But anyway. And then this black dot here, or both black dots, separate digits with a 1 to 2 ratio. So if this was a 2, this could be 1, because 2 is double 1, or this could be 4, because 4 is double 2. All right, and not all dots are necessarily given. So if I have 2, 4 here, there's no black dot, that's perfectly fine. If I had 2, 3 here, there's no white dot, that's perfectly fine. Both of those scenarios would be allowed. The dots only tell you about the 2 cells they touch, no other cells. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. So I'm going to start by coloring. Green, purple, orange. So I'm starting at the beginning of the line here. And whatever this digit ends up being, it's going to be a low, medium, or high. We're going to call that green. We don't know if green is low or medium or high, but we do know it's one of them. And then this one, we know is not the green group because these 3 need 1 of each. So we can't repeat the green group this early. And so we're going to call that the purple group. Whatever digit it is, it's going to be different than the green group. And then the orange group is our third one because we have 1 of each. Now, if you look, this group of 3 also needs 1 of each. But we've already encountered all 3 groups. We've given each one a color, green, purple, orange. We don't know which is which, but they're all colored. And so there's only one color that this can be because this group of 3 already has the purple and orange. So the only color left is the green. And this is going to cycle, right? Because now these 3 need 1 and it's only the purple. So the cycle is green, purple, orange, 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 green, purple, orange. And so now what we know is that there are 2 of each color in every row, column, and box. And so that can help us continue our coloring. So for example, this cell here, it sees 2 purples and 2 oranges. So it can't be purple or orange, it must be green. And then this row can finish with an orange. Now we have 2 oranges in the box, and this cell sees 2 purples. So this is green, and then we finish with a purple. This column finishes with a purple, and now this row finishes with an orange, and so this box finishes with a green. This column finishes with purple. Here we need the orange for the column. The box finishes with green. I might be able to just color everything right away. This is orange. All right, these are both purple for the column. This is orange, and this is green. All right, so we have everything colored, so we're done, right? So now here's where the black dots are going to come in, right? So we know that green is involved in 2 different ratios. Why do I know that? Well, because this is with orange and this is with purple. Orange and purple can't have the same digit in them. And so there is only 1 digit that can be in 2 different ratios, and that is the 2, because you can go 1, 2, or 2, 4. There is no other digit that can do that. In a 6x6 at least. In a 9x9, you can use the 4. You can do 2, 4, and 4, 8, but 8 is too large for a 6x6. All right, and so that means that these are a 1, 4 pair. We don't know which is 1 and which is 4, but actually interesting. Whichever one is the 1 ought to be, hold on, I made some logical error here. Because whichever one is the 1 needs to also be in the green group. Maybe I thought about this wrong. Hold on. Did I color it wrong? Do I have any mistakes in coloring? I don't think so. Everything looks good color-wise. Okay, let's think about this again. So just across a black dot, right? We could do a 1, 2, but obviously these aren't 1, 2. And so really, we just have to think about what the low digit is, right? In fact, I'm just going to think about this one on its own. This could be a 1, 2, but it can't be because they would both be low and therefore they'd both be green. So we can't do 1, 2. If we did 2, 4, that would actually work because whichever one's the 2, it can go with the 4. They're in 2 different groups. That's okay. We could do 3, 6 because that's okay. That one's medium, one's high. So, the mistake I made was assuming that these had to be the same digit as each other. And I think we just proved that they aren't the same digit as each other. So, these are the same group. So we need 2 digits from the same group that can both go with a different group. So this has to be the medium group. Right. So we know they're not the same digit because if they were the same digit, they'd have to be the 2 to go with 2 different digits with it. And we just show that that's not possible because one of them would be a 1 and that would have to also be the green group. Now they can't be a 1, 2 pair because the 1 needs to go with a 2 and we can't do a 1, 2 across these at all because they would be the same group. And so the only 2 digits, so with 1 gone, we can do a 2, 4 and we can do a 3, 6. Those are the only other pairs we can do. And you can notice that that means that 3 and 4, this has to be the medium group. I hope I explained that okay. I feel like I'm overcomplicated that or maybe over-explained it. But anyway, this has to be the medium group because it's the only digit. It's the only group that has 2 different pairs that'll work into the orange and purple groups. All right, now this is interesting. If this was a 3, this would have to be 2 because we have a 3, 4 pair here. And if this was a 4, this would have to be a 5. So that's 2 or 5. Now we know that the 3 is going to go with 6 and the 4 is going to go with 2. So we can put a 2, 6 pair there. So we know, for example, that we know this is a 2, 6 pair. So we know that this can't be 2, 6 or 3, 4. So it's down to 1, 5 only. We got some interesting asymmetries here. Maybe we can take more advantage of. This also sees the 2, 6 pair. So this is also 1, 5. So this is the other 2, 6. These are both orange, but we don't know about 1, 2, 5, 6 yet. So this is 2 or 5. If it's 2, then this is 1. If it's 5, then this is 6. That's probably a good way to put it. Here, if this is 2, this is 1. And if this is 6, this is 5, because they have to be the same group, right? Then this 1, 5 now goes to this 2, 6. How's this going to resolve? I guess we'll find out. This 1, 6 goes to this 2, 5. Weird. And this 1, 5 goes to 2, 6. There's got to be something going on here. 1, 2, 5, 6. So how do these work together? Oh yeah, these can't both be 2. So this has to be 5, 6, right? Because neither of these can be 1. That's really interesting. Because if either of these was 1, then it would go with a 5 here or would go with a 6 there, and that doesn't work. Yeah, okay, just thinking about it another way. So this has to be 5, 6, meaning the purples are the high. So that's 6 and that's 5, and the oranges are the low. 1, 2, 1, 2. 2 goes with 4, so that gives us 3, 4. This is high, this is high. So we get the 1 and the 2 here. We get the 1, 2, 1. We get 2. We get 1, 2. This is 3, 4, and 3. That's 4 and 3. That's 4 and 3. That's 3 and 4. Okay, we get the 6 and the 5 here. We get the 6 and the 5 here. We get the 5 and the 6 there, and we're done. We inexorably, I think that's pronounced. As we inexorably move from order to chaos, the irony of you successfully ordering these digits is not lost. Interesting. All right, cool puzzle, Randall. That was obviously one for our theme week that we had. Again, we'll be filtering out in a higher density than usual as we continue this month. Cool, I enjoyed that. I liked how I could color the whole thing, but then it was a little bit of a puzzle to, maybe more of a puzzle than it should have been for me, but it's a little bit of a puzzle to figure out like how the green could be shared between these two, and it wasn't what I initially expected, which was neat. Cool. Well, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.